So this is just a brief look at my magnetic tuning system that I've been using on my capacitively loaded vertical ground plane experiment. And I've been noticing an intermittent problem where I'd get it to just about correct tune, let's say on 80, and then the tune would go off. And I'd go around the cycle again and get to nearly perfect, and then the tune would go off. I just brought it down and opened it up, and the magnet that I was using had become loose. So as it was turning and getting just about right, it would then move. And this has been one of my problems. I'm not one of these robotics guys. I wouldn't have a clue what's available. So I've literally been gluing a magnet onto a plastic disc. And the motor is what turns the magnet. And and when this closes, you might see here, there's the ferrite core, and that ends up against the magnet. Whoops, stuck on there. So, and the magnet turns with relation to the ferrite core. Now, this magnet, its two wide flat sides are its north and south. So if you imagine if it was like this, with its north and south this way, then its torus field is ducting around through that torus. And when it's this way, its torus field is at 90 degrees to the torus. So when its torus field is at 90 degrees, where the magnet's this way and its torus is, going that way, then it has minimum saturation on the core. And when it's this way and its torus is ducting through the core, has maximum saturation on the core, and essentially just reduces the inductance value. So I adjust the inductance value of the core by making this adjustment. And the magnet's also off-center, so it's not just as simple as this range. It's got this range sort of thing, but this is also not exactly centered, so it has a point where it fully saturates, then it turns around, and then it has a point where it minor saturates and then comes back around again. So so there's the magnetic tuning system. I've just re-glued it with super glue and baking soda and hope it holds. But if anyone's got any ideas of how I can firmly fix a permanent magnet to a geared motor system, that could be so helpful. So I'll be putting this back up for testing. While I'm here though, here's one of my other versions. So this is very, very similar. It's also a magnetic, remote operated magnetic tuning system. You send DC up the coax to drive it, just like with this one, except in this case, instead of turning a motor, I have an electromagnet, and this is my core here. Now this one has a small capacitor on, so I can trim and make adjustments and then do the main tuning via the inductance. But they're both essentially very much the same thing. There's basically a bias T arrangement to prevent the RF getting to the electromagnet in this case, and the motor in this case. So the motor's here, and of course capacitance to lift the DC from the RF side, and this is the control unit. So I just have the basically I've got it marked here actually. The DC RF, so that's like out to the antenna, and just the RF which is in from the radio, and of course the DC input. So this is the control unit. This one, instead of just this on off, or I could have like a rocker, reverse it, but I'd have to make sure the DC was the shielding, the RF ground to the antenna was had a capacitor to break it from actual ground, because if I reverse it I'd get a short. But I could have it as a rocker going clockwise, anti-clockwise, switching the polarity. But in this case I've simply got an on-off variable, so the there's a transformer in here basically, so I turn it on and then I can adjust my motor speed, or if I'm using an electromagnet, then this is where that's really critical, because I simply adjust the level that I want that electromagnet to be at for tuning. There you go. And there are countless configurations you can do with this. These two have a very similar coil arrangement, not quite the same. So the coil for this, as you can see, is here. So there's this is the primary. Essentially, it's not exactly following our normal standards of transformers, and this is the secondaries. Though it's very unusual. I'll probably do a video on it one day. Now this one is different. This has two secondaries. The transmitter itself is the primary. But they're both basically using conical bifilar Tesla pancake coils on the cores. There you go. 7.3, and thanks for watching.